Good day. I'm Abnay Jewa, the teaching assistant for the Industrial Automatic Control course, and we are going to have a tutorial session. Okay, we'll go through a few sets of past questions to help prepare you for your end of sem examinations. So, let's start. The questions will be sent to you, so we wouldn't spend too much time reading the questions. Let's just jump straight into answering it. Okay. So how this works is that we are charging and discharging liquid substances. So when your push button, when you press your S3, inlet valve opens, the reservoir begins to be filled. Once it's full, your mixer starts working. When the mixer stops working, then your valve 2 opens so that the liquid flows out, right? And then this happens 4 times. So we have your various sensors, and then there's a counter, there's also a timer in place. So right now we are being asked the operation of the inlet valve V1. The answer for this is A. Why? Because when you look at the sets for this, you see that you have your start push button. When you press your start push button is what starts the whole process. And you have I0.2, which is your empty sensor. Okay, so if your start push button is pressed, or you notice that the reservoir is empty, so the empty sensor is stripped, that is what is going to set the SR flip-flop for the inlet valve. And then for your reset, you have your stop push button or your full sensor. So it's either you press your stop push button or it becomes full for the for it to stop running. Okay, so one's answer is A. For question 2, which of the following correctly describes the operation of the motor? The answer for question 2 is D. Why? Let's explain. To set it, question 2 asks the operation of the motor. Okay, as mentioned earlier, your motor starts running after the valve is full. Okay, so sorry, the reservoir is full. Okay, so it is set by I0.1, which is the full sensor. Okay, once we notice that it is full, now your motor can start running, and it runs for a set amount of time. That is why it has a timer at its reset, and there's also a stop push button at the reset. Okay, so D. Now, the operation of outlet valve V2, question three's answer is A. Outlet valve V2 opens after the motor is done mixing. So when the timer ends, then it opens. Then you have at your reset side, you have your stop push button and I0.2, which is your empty sensor. So when I hope it's basically three's answer is A. Okay. Question 4. Which of the following correctly describes the operation of timer T1? 4 is also A. How timer T1 works is that when we notice that our reservoir is full and our full sensor is stripped, it will start a timer. Okay, so that the timer ends up starting the mixer. I hope it's clear to you. And then 5. Which of the following correctly describes the operation of the counter C1? Okay. How C1 works is that we are C1 answer is D, right? So to set it, you have I0.3. I0.3 is your start push button. Okay, so once you start the whole process, you've started the counting as well. You set the counter. Now, what is doing the counting? The counting is being done by I0.2, which is our empty sensor, because it's everything ends with the empty sensor, but with the reservoir becoming empty. Okay, so to give you an idea of how a full process is going to be, our reservoir is empty at the beginning, right? So we start filling it we press our start push button, we start filling it with water. The full sensor is stripped. So what happens next is that now our inlet valve is closed, the mixer starts running, then after some time your outlet valve is opened, so your empty sensor comes out. So you see that the whole process ends with the empty sensor being tripped again. So every time it comes back to the empty sensor, we can count 1. Okay, that's why the empty sensor is at the countdown side. Okay, so D is the answer for question 5. Question 6, which of the following correctly describes the operation of the lamp? Question 6 doesn't have its answer being there. Okay, so I would say it's a bonus question because the lamp, when you look at the question, it is stated that lamp H1 indicates the end of a cycle is activated. Okay, so if it's indicating the end of a cycle, if it's indicating the end of the cycle, then it should be set by the empty sensor, which is I0.2. But we don't have any of them being set by I0.2, right? And there isn't a proper stop push button as well. So that's why I'm saying that the answer isn't there. Okay. If you have any opposing ideas, please feel free to share after you get the video. Yes. Let's move on. The door of an electrical workshop moves upward to close when the push button S1 is pressed continuously. However, the door moves down to open when the push button S2 is just pressed. An upper limit switch S3 controls the extent of the upward movement of the door, and a lower limit switch S4 controls the extent of the downward movement of the door. The movement of the door can be stopped at any time by means of a stop button S0. I just realized I'm reading the question. I said we will not read the questions anymore. Let's let's get into answering the question. Um yes. So question 7 says which of the following functional block diagram programs represents the opening of the door? Question 7's answer is B. Now why? You would notice that the set for B is I0.1, which is the push button for opening the door. Okay, so we are looking at which of them represents the opening of the door. And the output is also the correct output, the contactor coil for opening the door, which is Q0.0. So right now, let's look at our reset to make sure everything's in place. You have your stop over there, your stop push button I0.0. You have your upper limit switch I0.3 to prevent it from going overboard, right? And then you also have Q0.1, which is the other door, right? Q0.1 is a contactor coil for the closing of the other door. Okay, and we want that. Wait, 7. Did I say the answer is B? I'm sorry. That isn't the answer. Okay, so you have your stop push button being noted coming in, and you have your Q0.1 as well being noted. The answer is supposed to be C. Sorry, I must have made a mistake as I was writing. 7's answer is C. Okay, so um I don't, yes, let me explain it well. Okay, so what is setting it? You have at your set, you have your push button for opening the door. Now let's explain what is at our reset. Your stop push button can stop this whole process. So you have your stop push button and it's been noted. That has been explained already. You have your upper limit switch. That doesn't need to have a knot because once it closes, once it goes to 1, it should reset it. Okay, so that's why that one doesn't have a knot here. And Q0.1, right, that is the contactor coil. So I meant D. The contactor coil for the closing of the door. Okay, and we don't want that to be working. We are trying to do some form of latching. So we are saying that if this is at 1, if this goes to 1, then we want our reset to end up going to 0. So I'm sorry, the answer is actually D. It's actually D. 7's answer is actually D. Okay, so please let's move on to question 8. Which of the following functional block diagrams represents the closing of the door? Okay, so the closing of the door, that means our output is now going to be Q0.1, which is a contactor coil for the closing of the door. And then our inputs. Right now we are using an AND gate, we are not using an SR flip-flop, so a few changes will come in. Okay, so it's an AND gate, so we are trying to see the conditions for which our output is going to be 1. Now I0.2 is a push button for closing the door, so we want that to be at 1, so I0.2 is there. I0.4 is our lower limit switch. Okay, so I0.4 should be knotted coming in. Okay, so I0.2 should be coming in. I0.4, we want a knot on it because we are saying that once it is closed, we want the whole thing to come to an end. Close is equal to 1. Okay, so you have your I0.2, your I0.4 has been knotted. I0.5, which is your emergency switch, it should also be at 1. Okay, so that it goes to 0 when there's an issue. Okay, so that one is coming in with no issue. I0.0, which is your stop, should also come in, no issue. And then Q0.0, the contactor coil for the opening of the door should be knotted. So the answer for 8 is D. 8 answer is D. Okay, so we have a pulse diagram here, right? And question 9 says that what type of timer is being referred to? And the answer is an on delay. Okay, you would notice that I0.1 is your input. Okay, so when input from here, you can see it that I0.1 is your set. Okay, so when your input has come on, right, when it is at 1, it takes some time before your Q0.0 also goes to 1. Okay, and then that space of time was 5 seconds. That is the the operation of on delay timers. Okay, so this is an on delay timer, and then it takes 5 seconds before it outputs 1. So 9 is B, 10 is C. Okay, now figure 2 shows a PLC program written in functional block diagram for a given control circuit, right? And then we are asked to which of these correctly describes the control circuit in figure 2. And the answer for question 11 is B. Okay, so now let's go back and look at it carefully. 11th answer I'm saying is B. The last thing we are seeing here is our Q0.0. Same here. Now there's an AND gate here. So out of the AND gate comes Q0.0. You see that here. Your AND gate, the two things coming in are I0.3 and your output from the OR gate. So same thing showing here. And what's coming into your OR gate? You have I0.1, I0.1, I0.2, and then this it's picking from here to here, Q0.0. Okay, so those are the things coming in. Okay, so the answer for 11 is B. 12, which of these is the correct ladder program for the control circuit in figure 2? Instead of going all the way back to figure 2, we can just use this, okay, to explain it. So now we know that I0.1, I0.2, and Q0.0 are in an OR gate. OR gate is like a parallel arrangement, okay? So when you arrange them in parallel, it's yeah in essence implementing an OR gate. So I0.1, I0.2, and Q0.0 are in parallel. And then all of these together are in series with AND gate represents series. So in series we have the output from your OR gate and then I0.2, which will give you your Q0.0. So the answer for question 12 is A. 13. What happens when the push button I0.1 is given a momentary push? Okay, you figure 3 shows something. So when you look at the question, you see it. 13, the answer is D. Q0.0 comes on even when I0.1 is set to 0. Okay, and then 14, what happens to Q0.1 when the push button I0.1 and I0.4 are simultaneously given a momentary push? It's Q0.1 never comes on. Excuse me. Okay, so 1 and 1 in an SR flip-flop will give you 0. And when I0.1 and I0.2 are pressed simultaneously as well, Q 0.0 does not come on. Okay. So 15 is C. 15 is C. Now 16. Which of these is an industrial application for RS latching elements sustaining alarm signals? Okay. Such that when there's an input to it, it can be latched. We don't need to explain too much. 16 is B. 17. Question 17. What type of counter is... Okay, so we are looking at figure 4. And we are being asked what type of counter is being referred to if Q 0.0 goes off after the count of 20 tennis balls. Okay, it's a down counter that is being described. We are trying to say that if it goes to 0, then it's a down counter. You're counting from 20 downwards basically. And what happens if I0.4 is pressed when the counting is in progress? What happens is that your KW10 is set to 0. Okay, your I0.4 is your reset. Okay, so it will reset, it resets it to 20. So 18 is B. 18 is B. Since it's a down counter, it starts counting from a high number and starts moving down. So it will reset it to 20. 18's answer is B. 19. By default, what signal and at what input will cause the counter to change its count value by 1? Okay, 19's answer is C. Okay, at I0.2 with a signal changing from 0 to 1 and then back to 0. The answer is C. And by default, what happens to the BCD output when I0.2 is activated? That's QW10 is set to 20. Next question. An induction motor is set Okay, 21. An induction motor is controlled by means of a PLC such that 4 seconds after the motor has started in star, it changes to delta. Okay, so that it started by means of a push button S1. And then we have your stop push button S0 and an overload relay F1. Okay. Which of the following represents the activation of the supply means? Question 21's answer is A. Okay, from the question we know that it started by a start push button, which is your I0.1, and then it is ended either by your stop push button or your overload, your I0.0 and I0.2, to give you your output for your supply means, which is Q0, your mains contactor Q0.1. 21 is A. 22. Which of the following functional block diagrams represents timer 1? 22 is 22 is C. Okay, let's look at C. And we are looking at the output for the timer. Sorry, it's A. 22 is A. Okay. The output for operation time, the timer T1. Okay, so I'm sorry, it's actually C. I said A by C. Okay. Your star contactor has the output Q0.2. It has an output of Q0.2. So once your star starts, it will set your timer so that after the timer ends, it switches from star to delta. Okay, so it is C. 23. Which of the following functional block diagrams represents the operation of the motor in star? 23's answer is A. Okay, star starts immediately. So when you press your start push button, you start your mains and it starts in star winding. Okay, so your start push button is the set I0.1. And then to explain what's at our reset, we have Q0.3, which is our delta for latching. We are saying that if that goes to 1, we want to stop this whole thing. So our star and delta can't be running at the same time. I0.0 is your stop, I0.2 is your overload, and then T1 is the timer. Now its star runs for a set amount of time and then it switches to delta. So when the timer is done running, it's supposed to reset the star so that that one goes to 0 and then it should start delta. Okay, so 23 is A. Now let's look at this. Figure 5 shows a simple relay logic, right? And question 24 says that contact A should be controlled by 24's answer is A. Contact A, from here, the contact you are seeing here as A. When you look, when these two diagrams is the same thing. Actually, so this is the relay logic, and then this is it's being showed how it will be connected in a PLC. Okay, so you see that A is the same as this, what is over here as K2. Okay, so contact A is controlled by K2. For question 25, the functional block diagram output for K1 is, now the output for K1, when you look here, K1 is Q 0.1, so it's supposed to be 0.1, but for all of them he wrote for it was 4.1 that was used, so it's let's just go with 4.1. Okay, so Q 4.1. Now there's an AND gate. Okay, when you come here, you notice 1, 2, 3 in series. Series is an AND gate. Okay, so that's where your I1.1, I1.4, and Q4.2. But you notice that there's a branch here. There's a branch here. So now our OR gate is coming in. Okay, our OR gate is coming in here. And then the branch comes to Q4.1. Q4.1 is your K1. So your branch comes to pass through K1, right? Okay, so you branch and then you have an AND gate here, I1.2, I1.3. I1.2 is your S2, I1.3 is your S3 here. So another AND gate. So it comes to pass through here. I hope it's clear. But the answer is A. 25's answer is A. 26, the answer is also A. Similar logic, okay, but except now we swap the Q 4.1 and Q 4.2. Okay, so 26 is also A. 27, the functional block diagram output for K2 is the same question being asked here, 26 and 27, so the answer is also A. Now a 3-story building is being constructed, and let me just paraphrase this. So you have your story building. There are sensors from B1 to B4 at the 3rd floor. That tells you the position of the lift. You also have your push buttons from S1 to S4 to call for the lift. Okay, so we are being asked to answer a few questions with that. So when you come here, question 28 asks you, please give me a minute. Okay, 28 asks, which of them records the position of the lift from a general memory location to a specific one? Okay, so when you see something being copied or moved from one memory location to another, you know that you are using a move operation. Okay, so and we are being asked to move the position of the lift. Okay, now where is the position of the lift stored? It is where the sensors for position of the lift are. So the sensors for the position of the lift, right? That's your B1 to B4, which have their addresses I0.5 to I1.0. Okay, so I0.5 to I1.0, the answer is II. So you see, you get information on this coming in here. It is actually it's stored at MW14 and then it is moved to MW16. So you have your position being stored finally at MW16. Okay. So 28's answer is B. 29. Which of the following PLC programs records the request for a lift? Request, you make a request with your push buttons. And then the push buttons were I0.1 to I0.4. When you look at the table, you see that as being stated. From I0.1 to I0.4 are your push buttons. Okay. And then you move that to MW12. So your request is being stored at megaword, the memory word 12. Okay, so question 29's answer is A. Question 30. Which option below describes a PLC program that requires the movement of a lift upwards? 30's answer is A. Now, for a lift to move upwards, the request has to be higher than the position. To explain this better, if let's say I'm on the third floor and the lift is on the ground floor, if I call for it, it will end up having to move up because my request for it was higher than the current position of the lift. Okay, so 29, um, um, sorry, we are on question 30, the movement of the lift upwards. And I said the answer to question 30 is A. A is I. So let's go and look at that diagram for it to explain a little. So I. Okay, you have your comparator here. We mentioned that at memory word 12, the request is stored there. Okay, and then at memory word 16, the current position of the that's where the current position of the lift is. Okay, and then we are saying that for it to move up, the request has to be higher than the position. So that means that the value at MW16 should be greater than the value at MW12. So when you look at the comparator here, you would see that there's a less than to say that MW12 is less than 16, which is to say that the request is lesser than the position. This, I hope it's clear. In fact, it's a recorded session. You wouldn't be able to respond. Forgive me. Wait, give me a sec. Let me look at it carefully again. Sorry, I said to move up, the request has to rather be higher than the position. That means it's IV. Okay, it's IV. The answer is IV. IV, which is B. 30's answer is B. Okay, forgive me for that error. And then which options, the lift moving downward. Okay, so for the lift to move downward, okay, so for the lift to move downward, the request has to be lower. The request is stored at memory word 12, and then the position of the lift is at memory word 16. So we are saying that for the lift to move down, memory word 16 should be greater than memory word 12. Okay, so in which of these ones is 16 greater than 12? Um That's I. Okay. So 16 greater than 12 is the same thing as saying 12 is less than 16. So 12 less than 16. Okay. So I. That means question 31's answer is A. 31 is A. 32. In which of the following situations can the output of a retentive on delay timer go off? Okay, it goes off when the reset goes to logic 1. So the answer for 32 is C. 33. Two containers A and B are required to be filled in 10 through a main valve V0. Okay, so we have You have your valve V0, valve A, valve B. Valve V0 fills valve A and valve B. Okay. Valve A and B each have a full sensor and an empty sensor, right? And when filling, valve A or valve B opens first before some time will pass before valve zero opens. But when it is discharging, or when it is full and we are rather closing it, sorry, when it's closing, valve zero closes first, then after some time valve A or valve B closes. Okay, I'm just paraphrasing the question. You would have to look at it carefully on your own. Okay, so now let's answer these questions. Which of the following PLC programs correctly describes the operation of timer T1? Of timer T1. Question 33's answer is B. Okay, so now let's explain how T1 works. Q0.1 is your output for valve A, and Q0.2 is your output for valve B. Okay, and those are the ones which will set it. As mentioned, it wasn't stated clearly valve A is being filled or valve B is being filled. And usually one comes before the other. That's why we have either one of them in an OR gate coming into our set for the timer. Okay, and your timer has been set for 10 seconds. Okay, and when that ends, then it closes. Okay, now the operation of the timer was stated here. The operation of timer 1 was stated here that um it said, I'm trying to find where it was stated clearly to you. Please give me a second. Okay, it's at this side. Okay, so it says that when the containers sorry are empty, the sensors S3 or S5 immediately causes valve VA or VB respectively to open at once. So once valve V and VB opens, then the main valve, however, opens 10 seconds later. So that means that VA and VB sets the timer so that 10 seconds later, VB will open, the V0 will open. Okay, beautiful. Now timer T2. T2 operates in a slightly different way. When you look at the question, it says that when it is full, V0 closes at once, and then VA or VB closes 5 seconds later. So now V0 is the one setting it. Okay. So question 34, and 34's answer isn't there, but I would have chosen B if the NOT wasn't here. Okay, because there's a NOT gate setting it here. That's why I'm saying that the answer isn't there. If not, it should have been B. Or B and C, they are the exact same thing, but the NOT gate shouldn't have been there. Okay, so let's move on. Question 35. Question 35's answer is D, the operation of valve VA. Now let's explain it. First, we'll look at the output to make sure the output is correct. Valve VA has an output of VA. The output is supposed to be Q 0.2. Sorry, Q 0.1. That means that there's a mistake actually. There's a mistake. All of them have Q 0.2 or Q 0.0 as their outputs, but it's supposed to be Q 0.1. Okay, but ignoring that, the answer is supposed to be D. Okay, so let's explain it in that sense. What is setting the SR flip-flop here? We have Q 0.4 and I 0.3. Where Q 0.4 is our lamp, and I 0.3 is the empty water level float switch. Please give me a second.